In this video, I'm going to show you how to express sentences as algebraic expressions using variables. Here we want to translate the following sentences into algebraic expressions, the sum of 3 and 4 and the difference of 2 and 6. First of all, let's look at the sentence on the left here, the sum of 3 and 4, and let's convert whatever words we can to mathematical notation. So first of all, 3 and 4, those are just numbers. So 3 is just the number 3, and 4 is just the number 4. Okay, and then the sum represents an operation between these two numbers. Sum is just indicated by the addition symbol, plus. Okay, so you might wonder, the sum of 3 and 4, does that mean 3 plus 4, or does that mean 4 plus 3? We know that plus is between them, but what goes on either side? Well, the convention for doing this is that we just read it left to right. 3 is the first number that appears, so that is going to be on the left here, and then 4 is the second number appears, so that is going to be on the right. So the sum of 3 and 4 just means 3 plus 4. Okay, so now let's do the difference of 2 and 6. Difference means subtraction, so let's write that down, that's subtraction, and then 2, that's the number 2, and then 6 is the number 6. So like before, we're going to put our symbol in the middle, our operation here, and then our 2 and 6 are going to go in the order that they are read from left to right. So 2 comes first, so 2, and then minus 6 comes second, so 2 minus 6. That's our result. This example here illustrates the importance of order. In the previous example here, the order was just a convention and it didn't affect the result much. You could do 3 plus 4 and you get 7. You could do 4 plus 3 and you get 7. But in this example here, the order does affect the result. 2 minus 6 is negative 4. But if you flip the 2 and 6 around and you do 6 minus 2, then you get positive 4, which would not be correct. Alright, let's translate some more sentences. This time these sentences involve the use of variables. So first of all, the sum of a number and 5. What do we do here? Well, sum we know that is plus. That's pretty straightforward. 5 we know that's just the number 5. What about a number? What does a number mean? We're not told what the number is, so what do we do? Well, what we can do here is we can assign a variable, say x. X can be a placeholder for the number. And then we can treat the plus, the x, and the 5 just like we did before. We just treat x and 5 like numbers and read them from left to right and put our operation between them. So starting with x, and then our operation plus, and then our number 5. So x plus 5. There we go. Okay, how about the difference of two numbers? This time we've got a difference. We know what that means. That just means subtraction. But what about two numbers? So we're going to do a similar thing to what we did here. We just put in x for a number. That was our placeholder. Now we've just got two numbers, so we'll use two variables. So the difference of, let's say, x and y. X and y will be our two variables. And then we just read them right to left like we did before. X comes first. So x, and then our operation, minus, and then the second number, or variable in this case, y. So that's our result, x minus y. Here are two more sentences for us to translate. 15 less a number and 15 less than a number. And this is going to illustrate the difference between less and less than. It's a very important difference. These two sentences do not have the same meaning. So first of all, 15 less a number. Let's write our symbols, numbers, variables. Let's write them all here. So 15, that's just the number 15. Less means subtraction. And then a number, well, we need to assign a variable to this number. Why don't we call it x? So a number will be x. So 15 less a number. Less is our operation, and then we just read the numbers or variables from left to right. So 15 is the first one that appears, then we put our operation between, less, and then we've got our variable x. So that's our result, 15 minus x. Now in this second sentence, the word than makes a bit of a difference here. So we've still got 15, that's just the number 15, and less means minus, and number, that's just going to be a variable, x. But the word than here tells us that this time the number is what we start with, and then we subtract 15. So with than, we switch it around. Than causes us to put the right number first on the left, and then minus the left number second on the right. So x minus 15. Now that might seem a little strange, but it's necessary for our expression to mean the same thing as our sentence. For example, if x is 20, then our sentence becomes 15 less than 20, and 15 less than 20, well, we know that's 5. And our expression becomes 20 minus 15, which is also 5. So yeah, it checks out. That's the right way to do it. Here are two more sentences, twice a number and half a number. Let's start out with twice a number. So twice, that refers to 2, and then a number, we'll just assign a variable here. Why don't we call it x? Okay, so what's our operation here? Well, our operation isn't explicitly said in the sentence, but when it's not explicitly said, then we can assume it's multiplication. So twice a number, 2 of a number, that just means 2 times the number. So we're going to write 2 times the number x for our variable. In algebra, we usually use the shorthand 2x to represent 2 times x. We just forget about that multiplication symbol and just write the number and the variable together, and it means the same thing, just 2 times x. So 2 dot x, 2 times x with that multiplication symbol, and then 2x without any symbol between, they all mean the same thing. They all mean take 2 and multiply it by the number, twice a number. So any of these answers is correct. With half a number, it's pretty much the same idea, except now we're dealing with a fraction. So half, the fraction half is written as 1 over 2. And a number, we can just assign that to be x again. So our result, we can write a half times x with a dot, or we can write a half times x with a multiplication symbol, or we can write just a half x as algebra shorthand for a half times x. Either of these answers will be correct. Okay, 2 more sentences. First of all, there's 3/4 of a number, and that's kind of like the previous sentence we did. We just have a bit of a more complicated fraction this time. So 3/4, that fraction is 3 over 4. And then of a number, our number can be just x. So 3/4 of x, of, that just means multiplication, so times. And let's make that a dot just so we don't confuse it with that x there. So we can write this as 3/4 times x. And then to use algebra shorthand, we can just write that as 3/4 x. So let's just use that, 3/4 x. Our sentence on the right here is a little bit more complex, the sum of 2/3 and 1/5 of a number. So let's just assign some numbers and symbols here. So 2/3, that's just the fraction 2 divided by 3, and 1/5 is just the fraction, that's 1 over 5. And then of a number, well, a number, we can just call that a variable. We'll have a placeholder x. Okay, and now of, remember, that means multiply, so we'll put a dot, and then the sum means plus. Okay, wow, so we've got 2 numbers, a variable, and 2 operations. So what do we do here? So multiplication is what you should always do first. Always worry about the multiplication first. So 1/5 of a number, so that'll be 1/5 times x. And you can group that all into a single quantity here. 1/5 x. So now you think the sum of 2/3 and 1/5 x. You treat the 1/5 x as a single entity. So the sum of 2/3 and 1/5 x, well, you just start out with 2/3 and then put an addition sign between that and the quantity 1/5 x. So 2/3 plus 1/5 x. And to use algebra shorthand, we can just write that 1/5 x as 1/5 x without the multiplication symbol. So 2/3 plus 1/5 x. Here's our last set of examples. We've got two sentences. Both of them are pretty long compared to what we've been dealing with. So the first sentence, the sum of 1/3 of a number and 4/5 of another number. Let's start assigning numbers and variables and operations here. So sum, that means plus, of 1/3 of, so 1/3, that's just the fraction, 1/3, and then of means times a number. A number, we can call that just a variable x, and then 4/5, that's another fraction, 4/5, and then of another multiplication, and then another number we can call that, why don't we call that y? Okay, so remember that when you've got multiplication, you should deal with the multiplication first and then treat it as single entities when you're dealing with the addition. So first of all, we've got 1/3 of a number, 1/3 times x. So let's write that down. 1/3 times x. That's going to be a single entity that we're working with. 1/3 x, and then 4/5 of another number. So let's write that down also. So 4/5 of, so times another number y. Okay, so we've got these two single entities, and then we want to take the sum of them. So that just means add them up, put a plus between them. And using algebra shorthand, we can write that as 1/3 x plus 4/5 y. And there we have it. We're done. For this next sentence here, it's going to be a very similar idea. So starting off assigning symbols, numbers, variables, the difference just corresponds to the operation of subtraction, and then 3/4 of a number. 3/4 is the fraction 3/4, then of, that means multiplication, and then a number, let's assign a variable, why don't we call that x, and 7/10, that's a fraction, 7/10 of, that's another multiplication, another number that needs to be another variable, so let's call that y. Again, we want to do the multiplications first so that we can simplify how we're thinking about our sentence here. So first of all, there's 3/4 of x, 3/4 times x, so we'll just write 3/4 dot x, and then 7/10 of another number y, so 7/10 dot y. And what are we doing to these two entities? Well, we're taking the difference of them. So difference, that's subtraction, so put a minus sign between them. So the result then, using algebra shorthand, we will get rid of the dots here and just write 3/4 x minus 7/10 y. And there we go, that's it. In the future, we'll also learn how to express sentences using more complex algebraic operations, such as exponents and roots.